From a bold idea in ancient Greece to the force that reshaped the 20th century, this is the story of the atom. How did tiny, invisible particles become the key to both unimaginable energy and devastating destruction? The idea of atoms began as pure philosophy. Around the 5th century BCE, Greek thinkers like Democritus imagined that all matter was made of indivisible particles called atoms. For centuries, it was just a thought experiment, a compelling idea with no proof. That all changed when modern chemistry gave the atom scientific teeth. In the early 1800s, an English chemist named John Dalton proposed that different elements were made of distinct atoms and that these atoms combine in fixed, predictable ratios to form compounds. This crucial insight turned atomism from a philosophical concept into a testable science. But just as science proved atoms were real, it also began to reveal they weren't indivisible after all. By the late 19th and early 20th centuries, a series of groundbreaking experiments showed that atoms had parts. In 1897, J.J. Thomson discovered the electron, a tiny, negatively charged particle. A few years later, Ernest Rutherford's famous gold foil experiments revealed that most of an atom's mass and its positive charge were concentrated in a tiny, dense core he called the nucleus. The picture wasn't complete, though. It was until 1932 that James Chadwick discovered the neutron, a particle with no electrical charge, but one that was absolutely crucial, residing right there in the nucleus. The one solid atom was now a miniature solar system of subatomic particles. A profound conceptual turning point arrived with Albert Einstein. His famous equation, E = mc², revealed a mind-bending truth: mass and energy are two sides of the same coin, they are interchangeable. This didn't by itself build any weapons, but it laid the theoretical groundwork. It explained how a tiny, almost imperceptible change in mass inside an atomic nucleus could unleash an enormous, almost incomprehensible amount of energy. A small amount of mass could equal a huge release of energy. The theory became reality in the late 1930s. In 1938, experiments with uranium by Otto Hahn and Fritz Strassmann produced bizarre results they couldn't explain. They shared their findings with their colleague, Lisa Meitner, who, along with her nephew Otto Frisch, correctly interpreted what was happening. A heavy uranium nucleus wasn't just chipping a piece off, it was splitting into lighter pieces. They called this process fission. Most importantly, they realized that this split could release additional neutrons. That single observation was the key, suggesting for the first time that a self-sustaining chain reaction might be possible. Scientists quickly realized the terrifying implications. If one fission could produce neutrons that triggered more fissions, an explosive, exponential chain reaction could occur. This possibility deeply alarmed researchers, especially as the world descended into the chaos of World War II. In 1939, a group of concerned physicists, including Albert Einstein, warned the United States government about the potential for unparalleled military applications. In response, the U.S. and its allies launched a massive, top-secret program to explore the science and engineering of nuclear chain reactions, the Manhattan Project. The race was on. On December 2, 1942, a monumental milestone was reached. Under a squash court at the University of Chicago, a team of scientists led by Enrico Fermi achieved the world's first controlled, self-sustaining. The research culminated in the first atomic explosion at the Trinity test in July 1945, and just days later, the horrific bombing of Hiroshima and Nagasaki. The human cost was immense and left a permanent scar on the world's conscience. At the same time, this powerful new science led to incredible civilian technologies. Nuclear power began to light up cities, medical isotopes were developed to diagnose and treat diseases, and our understanding of physics and materials science leapt forward. The atomic age brought unprecedented technical progress, but also new geopolitical tensions and deep ethical questions that continue to shape our world today. From a philosophical idea whispered in ancient Greece to a force that reshaped geopolitics, technology, and our very sense of security, the story of the atom is one of brilliant discovery and profound responsibility. Understanding that history is crucial for engaging with today's debates about science, safety, and ethics. If you found this journey through science history interesting, please like this video, subscribe to the channel, and ring the bell so you don't miss our next story. Thanks for watching.